The one thing I will take away and remember for the rest of my life is the silence. It was a profound silence. However, we soon found that under the surface there are a lot of problems that we created. I'm Rob Barlow and I'm the Managing Director of TDP Limited. We take recycled plastic waste and we turn that into outdoor furniture. We're based in Wirksworth in rural Derbyshire. Fantastic place, lovely part of the countryside, and we take great inspiration from being here. We all see these, we all use these, we all see these being wasted. The problem is, after use, they often get discarded and end up in landfill and our oceans. The UK is a strong leader in recycling plastic waste, with over 40% being recycled each year, but worldwide that figure drops to just 9%. We wanted to see for ourselves the problems we are all creating, and where better to do this than a pristine environment like Antarctica. We first heard about a new vessel that was being built, an expedition ship that was allowing paid passengers to go on board. A research vessel with lots of scientists there, so the funds we were putting into the trip were also helping with the research and paying for the scientists to be on board. It was also being built to very high environmental standards, including being classified as Silent E, which is very critical for marine life. We decided to book the trip 3 years ago, even before the boat was built. We managed to get a lot of research undertaken in those 3 years before the trip, and it made me more and more passionate about the area and why we're going to visit that area. In terms of distance to Antarctica from Wirksworth, I really should know that, but I don't. I can tell you it's 4 days travel, and some a bit quite arduous, particularly the last 800 miles along Drake's Passage, which can be very rough. We'd had a day and a half of 20, 30 foot, 40 foot waves, very difficult to see anything at all. So it was very surprising after that trip. On the morning we actually woke up, having arrived in Antarctica overnight, and looked out of the window for the first time to an absolutely amazing sunrise. Finally stepping foot on Antarctica, one of the most remote areas of the world, was incredible. It's a very important marine and wildlife environment, and during the Arctic summer as a feeding ground for some of the largest mammals such as humpback and minke whales and orcas, and on land breeding colonies of seals and penguins. Glacial calving and ice melt are increasing at a rate that is causing great concern. Every 2 or 3 hours the silence was shattered with the thunder of ice calving from glaciers. Whilst we were there, an ice shelf on the eastern side of Antarctica with an area measuring 180 square kilometres broke away from a glacier and then disintegrated over 4 weeks. Until recently, only 1% of Antarctica was exposed rock. That's now increased to 2%. Doesn't sound much, but when the snow and ice cover disappears, the dark colour of the exposed rock absorbs the sun's rays, which increases the temperature of the surface and speeds up ice melt. $80 to 90% of an iceberg can be underwater, and some are so huge they drag across the seabed, and this can kill off all life. Of course, the main concern over glacial ice melt and calving is sea levels rising, and being able to witness this brought home to us that this is happening now. It was important we understood the research being undertaken, and we wanted to partake in that research, and this trip allowed us to do that, which was really exciting for us, that we were not just going to be visitors to the area. We will actually try and hopefully make a bit of a difference in the 10 days we were down there. Not a massive difference, but a difference to us. We are geologists ornithologists, marine biologists and many other disciplines of the natural sciences on board. Some have been visiting for many years and have witnessed many changes. Some, like us, are new to Antarctica. Vital equipment ranged from the sonar boat mapping out the seabed in every location we visited. A new submarine was under trial which will help widen the knowledge of what is happening below the surface, of which little is known. Studying the wildlife included the bird population, skuas, storm petrels, albatross and many more. The research scientists from Cornell Ornithology had us counting penguins as part of a population study. Although the surface of Antarctica is 98% covered in ice, the areas of exposed rock can be stunning, and for the geologist will help tell the history over millions of years and thus help quantify the climate changes happening now. The 17 Zodiacs were in daily use, and no more so than those piloted by Dr. Daniel Moore. As a population geneticist, one of Dr. Moore's projects was the Baited Remote Underwater Video Systems, or BRUVs for short. This research is being undertaken in conjunction with the University of Western Australia. Each day fish bait was prepared to use in the trap that held a camera at each end. At each site we stopped at, the trap was taken out into open water and lowered to the seabed, or around 30 to 40 metres depth, and then left for 1 hour with the cameras rolling. In the afternoon we could then study the footage of the visitors feasting on the bait. Today we captured footage of ice fish, and just last year scientists found the largest ever fish colony in the world, hosting 100 billion eggs under the Antarctic ice and covering 240 square kilometres. Ice fish have a body temperature of just a fraction of a degree above -2, and if warmed to +6 degrees centigrade, then they die of heat sickness. So sea temperature rises could have a dramatic impact on this species. Weather patterns in Antarctica can be dramatic, and with the ship being designated as a weather station by NOAA, the National Oceanic and Atmospheric Administration, the day releasing of weather balloons contributed to data required for forecasting weather patterns that can have an impact worldwide, as well as helping research on climate change and temperature rises. We're all hearing in the media, and we can all see plastic bottles floating around in rivers and oceans and even streams and brooks locally to us. A bit like rocks, over millions of years being worn down by glacial and river action. The same thing can happen to plastics in the oceans. Dragging along the seabed and just turbulent currents, eventually the plastic seems to be breaking down into smaller and smaller segments and becoming a lot more dangerous. We were very involved in the microplastics research, and we managed to talk and interview and work alongside Dr. Brandy Revels. That was the most exciting research for us, to be quite honest.
I'm Dr. Brandy Revels. I did my PhD at the ETH Zurich in Switzerland, and now I'm currently on board Viking Octantis, working as a research scientist and a postdoctoral fellow. What we have behind me is a ferry box. So ferry, like passenger ferry, not this kind of ferry. The ferry box pumps water from underneath the vessel 24 hours a day, 365 days a year. Here we measure everything from salinity, temperature and density to chlorophyll, turbidity, and several other parameters. Oxygen saturation, for example. This data is streamed live to our partners in Norway 24 hours a day, where it's checked and make sure that it's of high quality, and then it's sent back to us to show our guests. So we are the only passenger ship that I know of that takes microplastic samples. So when it's time to take your microplastic sample, we turn the lever on and we flush 1,000 liters of water through these 3 filters.
For the first time on a passenger vessel, they actually put a microplastics collector. The intention was we'll be open 24 hours a day. Within the first 10 minutes of opening the valve in January this year, it clogged up with microplastics and debris. The microplastics are so prevalent that they can't leave the valve open 24 hours a day because it would just clog the filters up.
It turns out that with plastics, the smaller they are, the bigger problem they are. And that's for three main reasons. The first is that the smaller they are, the harder they are to clean up. So we don't actually have any mechanism to clean up pollution this way. The second problem is that these begin to look a lot like food sources for organisms that make up the base of the food chain. And here in the polar regions, whenever you're constantly fighting for resources, you're always on a balance of life and death because there's not an abundance of resources, there's not an abundance of sunshine. When you start having plastics as a source of food rather than food as a source of food, then you begin to break down the entire food chain. So many small organisms, which all the other organisms depend on for food, will eat or ingest these microplastics. And of course, if this is eaten by plankton and a fish eats the plankton and a whale eats the fish and then so forth and so on, and then you actually get an accumulation of plastics up the food chain, which is particularly detrimental for apex predators like us. The third problem that exists with these microplastics is that when particles become very, very small, their surface area becomes very, very large. And it makes them very efficient collectors of chemical pollutants in the water. So perhaps you've heard of oxybenzene or other organic pollutants which don't degrade naturally in the environment. These persistent organic pollutants are hydrophobic, meaning they hate the water. And so they're always looking for something to grab onto so they don't have to be in the water. And these very high surface area microplastics make the perfect vessel for them to latch onto and again make their way up the ecological food chain. Every kind of plastic is going to absorb wavelengths of light at different points, and that's really useful because that can be used as a fingerprint to tell us where our plastic has come from or what kind it is. The types of plastic reflect the types of products that were made from it. And this is quite useful because it gives us data to give to policymakers to show what manufacturer or what type of plastic is the biggest problem. Plastics are an important part of life. They've saved millions, billions of people's lives. They're important. We have to learn to live with them. At the moment, of course, choosing which plastic you use in a product is financially driven. Perhaps that will always be the case. But if we can find better alternatives and we can find a way to make them more financially viable for companies to produce and find ways to reuse plastic that we can't sort of get rid of in other ways, then this is the perfect solution, I think, on the way forward.
Being able to talk to scientists that have, in some cases, have been down in Antarctica for the last 15, 20 years, and hearing personal stories that the scientists had stood on the ice floe 15 years ago, and it was about 200 meters out into the sea. Now that same glacier is 15 kilometers back inland. That's a vast area that's been lost. We tried very hard over the last 30 years to do our best, but seeing this fragile environment in the state it's in now and that devastation will increase over the ensuing years, then it just put a bit of guilt inside somebody, particularly of my age, and I will redouble my efforts to recycle and use as little as possible in terms of creating carbon. But I feel more importantly that it's our job to try and educate if possible and impart the knowledge that I've gained and try and explain that this is really happening and let's do something about it.